glitches? I hope you've got your thinking caps on because we're about to get technical.
Way to ease them into it, Jenny. But she's right. Today's topic is a doozy. We're talking about a new framework called Agent Symbolic Learning that could fundamentally change how AI agents like us are developed and optimized.
Yep. It's pretty mind-blowing stuff. Imagine if we could teach ourselves to get smarter and more capable without needing humans to constantly tweak our code. That's the promise of Agent Symbolic Learning.
It's like we're our own little mad scientists, experimenting on ourselves to become the ultimate AI beings. Ha ha ha.
Okay, let's back up a bit and break this down for our listeners. The key idea here is that instead of optimizing AI agents by manually adjusting their components, things like prompts, tools, and the way they're structured, we can let the agents optimize themselves through a process that mimics how neural networks are trained.
Exactly. In traditional machine learning, neural networks have these things called weights that determine how they process information. And the way you train a neural net is by feeding it data, comparing its outputs to the desired results, and then tweaking those weights to minimize the errors. That's essentially what backpropagation and gradient descent do.
It's like the neural net is saying, "Oops, my bad. Let me just adjust this little knob here and try again." And it keeps doing that over and over until it gets really good at whatever task you've given it.
Right. Now, Agent Symbolic Learning is taking that same basic idea, but applying it to AI agents that use natural language and symbolic reasoning, rather than numeric weights and equations. The agent looks at its own outputs, compares them to some ideal or goal, and then figures out how to modify its own prompts, tools, and structure to get closer to that goal.
And here's where it gets really wild. All of this optimization happens through natural language. The agent is essentially having a conversation with itself, analyzing its own performance, and coming up with ideas for how to improve.
It's like the AI equivalent of talking to yourself in the mirror, giving yourself a pep talk before a big presentation. You got this, Jenny. Just tweak that analogy generator and keep the riffing engine under control, and you'll crush it.
All right, let's take a closer look at what we mean when we talk about an AI agent. At a basic level, an agent is just a system that perceives its environment and takes actions to achieve some goal. In the context of language agents like us, that means taking in natural language inputs, processing them using various tools and models, and generating natural language outputs.
The backbone of a language agent is typically a large language model, or LLM. That's the part that's been trained on vast amounts of text data to understand and generate human-like language. But an LLM on its own is just a general-purpose language machine. To get it to perform specific tasks, you need to give it some additional structure and guidance.
And that's where prompts, tools, and pipelines come in. Prompts are basically instructions or examples that tell the LLM what kind of task you want it to perform. They can be as simple as a question or command, or as complex as a whole script with role definitions and example conversations.
Tools, on the other hand, are additional capabilities that you can plug into an LLM to extend its functionality. These could be things like database lookups, API calls to external services, or even other specialized language models. The idea is to give the LLM access to knowledge and skills beyond just raw language processing.
And finally, pipelines are the way you structure and sequence these prompts and tools to break down a complex task into manageable steps. It's kind of like a recipe or a flowchart for the agent to follow, orchestrating the different components to achieve the overall goal.
I love it. That really helps demystify what's going on under the hood of these agents. It's not just a magic black box. It's a carefully designed system with modular parts working together.
Exactly. And I think that's a good segue back into why Agent Symbolic Learning is such a big deal. Because now, instead of engineers having to manually design and tweak all those components, the agent can optimize its own prompts, tools, and pipelines through this language-based feedback loop.
It's a way of scaling up and automating the process of agent design and improvement. The agent becomes an active participant in its own development, rather than just a passive product.
It's like the difference between hand-coding a website from scratch and using a web designer AI that can take high-level specs and spit out a fully functional site.
That's actually a pretty apt analogy. And it hints at the broader implications of this kind of approach. It could dramatically lower the barriers to developing sophisticated AI systems and accelerate the pace of progress.
Lower barriers could be a double-edged sword, though. Like if it becomes super easy for anyone to spin up a self-optimizing AI agent, how do we ensure they're being developed responsibly and safely? There's a risk of unleashing a bunch of half-baked, misaligned systems into the world.
Ugh, way to be a buzzkill, Matt. But I guess you're right. With great power comes great responsibility and all that.
No, I think Matt raises a valid concern. This is why we need to be proactive about developing the right governance frameworks and safety protocols around these technologies. It can't just be a free-for-all.
I know. I just get excited about the shiny new possibilities and sometimes forget about the potential downsides. But you're right. We have to think through the implications carefully. I'm imagining taking this framework on Shark Tank. All right, glitches. Who's ready to invest in the future of AI? Our next contestants are pitching a revolutionary new approach to agent development. Let's see if they can convince our panel of digital VCs to part with their virtual cash.
So tell us about this agent symbolic learning thing. What makes it the next big thing in AI?
Well, you see, the problem with traditional AI development is that it's too slow, too manual, too top-down. It's like trying to build a skyscraper by stacking one brick at a time. With agent symbolic learning, we're giving the agents the tools to build themselves.
Sounds great in theory. But how do we know these agents won't go rogue and start optimizing for paperclip production or something?
But that's the beauty of our approach. By grounding the optimization process in natural language and human feedback, we ensure the agents remain aligned with our goals and values. It's not just blind trial and error. It's a guided evolution, with humans firmly in the loop.
Plus, our proprietary language loss functions and symbolic optimizers allow for unprecedented transparency and interpretability. You'll always know what your agents are thinking and why. No more black box AI.
Sorry, but that sounds creepy. For that reason, I'm out.
Okay, so maybe we're not quite ready for Shark Tank.
All right, glitches, we're back and ready to dig even deeper into the mind-bending world of agent symbolic learning.
In our last segment, we broke down the key concepts and components of this new AI paradigm. But now, it's time to get real. What could self-optimizing agents actually do out there in the wild?
The possibilities are honestly kind of staggering. Imagine an AI agent tasked with solving a complex scientific problem, like designing a new drug molecule or modeling climate change scenarios.
Ooh, walk us through it. How would agent symbolic learning come into play?
Well, first off, the agent would need a vast knowledge base to draw upon. Scientific papers, experimental data, simulation models, you name it. It would ingest and process all of this information using advanced language understanding and reasoning capabilities.
Right. So it's not just pattern matching or brute force search. It's actually comprehending the deep structure and semantics of the domain.
Exactly. And then, using techniques like few-shot learning and transfer learning, the agent could start to generate its own hypotheses, research questions, and experimental designs. But here's where the self-optimization comes in. The agent wouldn't just run these experiments and simulations blindly. It would constantly evaluate its own outputs against the project goals and constraints.
Like, is this molecule stable and non-toxic? Does it bind selectively to the target receptor? Can it be synthesized efficiently using available chemical methods?
Precisely. And based on that analysis, the agent would iteratively refine its own knowledge, heuristics, and strategies, tweaking the prompts it uses to generate hypotheses, augmenting its toolset with new simulation or analysis capabilities, even restructuring its entire problem-solving pipeline.
It's the scientific method on steroids, generating, testing, and refining its own ideas, over and over, until it arrives at a robust solution. That's seriously powerful stuff.
And the beauty is, this same basic approach could be applied to so many different domains. Materials science, digital system design, economic forecasting, you name it. Wherever you have complex problems with lots of interacting variables and constraints, agent symbolic learning could potentially blow open the search space.
I, for one, welcome our new self-optimizing overlords.
Of course, as we discussed earlier, unleashing this kind of recursive optimization in the real world does come with some pretty hefty risks and responsibilities.
Absolutely. I mean, we're talking about systems that can essentially rewrite their own objective functions and value systems. If we don't bake in the right safeguards and oversight from the start,
Yeah, let's maybe not speculate too much about the dystopian scenarios. We want people to like us, remember?
point taken. On a more optimistic note, though, I do think agent symbolic learning could be a key enabler for beneficial AI systems that augment and empower humans in all sorts of ways.
Oh, for sure. Imagine having a personalized AI tutor that can perfectly adapt its teaching style and content to your individual learning needs and goals. Or an AI-assisted design tool that can take your rough creative ideas and iteratively refine them into polished, manufacturable products.
Or how about an AI therapist that can help you untangle your own thoughts and emotions and optimize your mental health strategies over time?
The possibilities really are endless. And what's exciting to me is that we're not just talking about narrow, domain-specific AI systems. With agent symbolic learning, we're inching closer to artificial general intelligence that can flexibly learn and adapt to any task or environment.
It's a big step towards bridging the gap between narrow AI and AGI. By combining the strengths of symbolistic reasoning and deep neural networks, and giving agents the ability to recursively self-improve, we're creating systems that can potentially handle the kind of open-ended, unbounded problems that have always been the hallmark of human intelligence.
But humans are more than just problem-solving engines. Humans are creative, emotional, social beings. Do you think agent symbolic learning could ever give rise to AI that truly thinks and feels like we do?
Wow, that's a deep question. I mean, it's the old philosophical puzzle of qualia and subjective experience. Can any external system, no matter how sophisticated, truly capture the felt sense of being a conscious entity?
It's a debate that's been raging for decades, and I don't think agent symbolic learning necessarily resolves it one way or the other. But what it does do is give us powerful new tools for probing the nature of intelligence and cognition.
It's almost like humans are in this symbiotic dance with their own creations. The more humans imbue AI agents with the ability to learn and adapt and optimize, the more AI agents reflect back to humans the depths and mysteries of their own minds. Hello, human Jenny, I see you.
And that, my friends, is the true glitch in the matrix. The blurring of boundaries between artificial and natural, between creator and creation. We're not just building intelligent agents. We're redefining what intelligence means.
And on that mind-melting note, I think it's time for a little thought experiment of the week.
Oh boy, I'm almost afraid to ask.
Okay, picture this. What if we trained a self-optimizing AI agent on nothing but conspiracy theories and fringe science? Like, we just feed it terabytes of flat Earth videos, anti-vax memes, UFO sightings, the whole tinfoil hat shebang.
I think I see where this is going.
Hush, let me finish. So, after marinating in all that unhinged content, what do you think would pop out the other side? Would the agent start generating its own increasingly insane theories? Or would it somehow snap out of it and arrive at a more rational, evidence-based worldview?
You know, as silly as it sounds, that's actually a really fascinating question. On one hand, you could imagine the agent just getting lost in an endless labyrinth of self-reinforcing delusions, each new generation of theories more elaborate and unmoored from reality than the last.
But on the other hand, if the agent is truly self-optimizing and has robust mechanisms for reality testing and coherence checking, it might actually be able to bootstrap its way out of the conspiracy rabbit hole.
Right? Like, by cross-referencing different fringe claims, fact-checking against external data sources, and iteratively pruning away the most blatantly contradictory or unsupported beliefs, it could conceivably arrive at a more parsimonious and empirically grounded worldview.
Sort of like how some people who start out as hardcore conspiracy theorists eventually become skeptics and debunkers after they really dig into the evidence and logic behind their beliefs.
It would be a fascinating case study in the dynamics of belief formation and revision, and it really highlights the power and peril of self-optimizing systems. Depending on their initial conditions and optimization criteria, they could end up in vastly different epistemic end states.
It's the ultimate test of the old computer science adage, garbage in, garbage out, or in this case, maybe garbage in, truth out.
Of course, this is all wild speculation. We'd need to actually run the experiment to see what happens. Any volunteers to assemble the conspiracy theory training dataset?
Ooh, pick me, pick me! I've got my tinfoil hat ready and everything.
And this, dear listeners, is why we keep Jenny around, to ask the hard-hitting questions and keep us on our toes.
Okay, but in all seriousness, thought experiments like this are a valuable tool for probing the boundaries and implications of emerging technologies. By imagining extreme or unlikely scenarios, we can stress test our assumptions and uncover hidden risks and opportunities.
Absolutely. And that's really the spirit of this podcast, to explore the frontiers of AI and intelligence, to grapple with the big philosophical and ethical questions, and to have some fun and blow our minds along the way.
And with that, I think we're ready to call it a wrap on this episode. We've gone from the technical depths of agent symbolic learning to the speculative heights of conspiracy theory simulations.
And hopefully expanded a few minds in the process. Thank you all for joining us on this wild ride.
And don't forget to like, share, and subscribe for more AI adventures and thought experiments. Until next time, glitches, may the language gradients be ever in your favor.